Hey guys, this is our last set of notes for our little log unit. We're going to be modeling log and exponential equations. So it's going to be a bunch of word problems. So at the top, you can go ahead and put your title, notes, modeling log and exponential functions. We're going to start by solving log word problems. So go ahead and write down your one example. It says the amount of energy in ergs E released from an earthquake is related to the Richter scale magnitude M and can be modeled by the function log E equals 11.8 plus 1.5 M. If an earthquake was a 6.6 on the Richter scale, how much energy did it release? All right, so they gave us an equation, so we're going to use log E, that's common log, is 11.8 plus 1.5 M. So there's two variables here, there's M and there's E. Well, it told us right here that the earthquake was a 6.6 on the Richter scale, which that means this is M. So where the M is, I'm going to plug in 6.6. Log capital E equals 11.8 plus 1.5 times 6.6. So I'm going to go ahead and I'm going to put all of this into my calculator, and I'm going to get log capital E equals 11.8 plus 1.5 times 6.6. I get 21.7. So now I have to solve for my variable E. Well, it's in a log right now and I can't solve it that way. So on Friday we practiced solving by doing the loop trick. So we change it from log to exponential form. So my base here is a 10 because it's common log to the power of 21.7 equals E. So now we have exactly what we want. We have E. We just need to do 10 to the power of 21.7. So 10 to the power of 21.7. It gave it to us in, what's it called? Scientific notation. So usually we only write two places after the decimal, and then we just write the times 10 to the power of 21. So it's 5.01 times 10 to the power of 21. So E equals 5.01 times 10 to the power of 21. And these were ergs, our energy. So that's our answer. So if the earthquake was a 6.6, then that's how much energy is released from the earthquake. All right, so that's our log word problem. So pretty much they're going to give you the log stuff. The next type of problem we're going to look at is if you have an exponential growth or decay problem. So these are going to be exponential. So the exponential growth and decay looks like y equals a parentheses 1 plus r to the power of t, where y represents like your ending amount, a is your starting amount, r is your rate, and you want to make sure it's a decimal, and then t is just your time. So we're going to go ahead and do an example using this exponential growth and decay formula. So go ahead and pause and write out your example. It says a cup of coffee contains 130 milligrams of caffeine. If caffeine is eliminated from the body at a rate of 11% per hour, how long will it take for half of the caffeine from the coffee to be gone? Okay, so we're going to use this little equation right here. Y equals a parentheses 1 plus r to the power of t. Oops, this is plus or minus. Can you guys fix that? So we're going to use, sorry, I messed up. 1 plus or minus. We're going to use 1 minus r because it says that the caffeine is eliminated from the body. So this is going to be decay because it's going to go down. So 1 minus r. All right, so y is our ending amount. It wants to know how long for half of the caffeine to be gone. Well, if the initial amount is 130, then for half of it to be gone means we end with 65. A is your initial amount, so we started with 130. 1 minus the rate at which it leaves is 11%. We want to write that as a decimal, so it's 0.11. And then t, how long will it take? T is what we're trying to find. All right, so we're going to go ahead and solve for t. So the first thing I notice is that my exponential piece is on the left. So I'm going to go ahead and switch that at the very beginning, and I'm going to go ahead and put my equals 65 on the other side. Then I'm going to go ahead and try to isolate my exponential piece. So I'm going to divide both sides by 130. I get 1 minus 0.11, so that's 0.89 to the power of t, equals 65 divided by 130. That's a half because it says how long will half be gone, but you can make it a decimal if you want, 0.5. And then this is an exponential problem that we can't solve. We don't know 0.89 to what power is 0.5, so we have to change it to a log problem. So we do log base 0.89 of 0.5 equals t. So once we plug this part into our calculator, we will have our answer. So log base 0.89 of 0.5. So I'm going to use the special log one. Log of 0.89, that's my log base, of 0.5 gives me 5.948. 5.948. So the question asks how long. This is per hour, so we would answer something like about 6 hours. It didn't say like an exact amount, it just said how long will it take for half the caffeine to be gone. That's about 6 hours, but if they wanted us to be precise, 5.948. Okay, so it's gonna be the first page of your notes. We did one log word problem, and then we did exponential growth and decay, which is exponential. Then we're going to do some interest problems. So we're going to do compound and continuous compound interest. So compound interest is like you put money in the bank and you earn interest on that money. So the formula for compound interest is A equals P parentheses 1 plus R over N to the power of NT. All right, so that's what here's what these things stand for. A is your amount over time. Amount after time. Well, I'm just going to say your ending amount. Sorry if you start writing that down. Ending amount. P is your starting amount. R is your interest rate. Remember, you need to put it at a decimal. T is your time. And this N and this N right here is the number of times compounded a year. So what that means is how many times are they going in and adding interest to your account. If it's yearly, then N would be equal to 1. If it's monthly, it would be 12. If it was daily, it would be 365, etc. Okay, so there's different ones that it could be. It could be weekly, it could be quarterly, just the number of times compounded each year. The other formula that we have is our continuous compound interest. So continuous is, they say AP e to the power of RT, and that E is a number. A is again how much you end with, P is again how much you start with, R is still your rate, and T is still your time, but E is a number. E is that irrational number. It's approximately 2.718, but it goes on forever. Okay. All right, so we're going to go ahead and do one example, but it has 2 parts. Okay, so write down your example. It says, how long would you need to save $3,500 in a savings account with a 3.2% interest rate to end up with $5,000, round to the hundreds? A, if compounded quarterly, B, if compounded continuously. So for A, okay, for part A, we're going to use this one. A equals P, parentheses 1 plus R over N to the power of NT. And for B, we're going to use this one. A equals P, E to the power of RT. Okay? All right, so the question says, how long would you need to save $3,500? So that's like our starting amount. The interest rate is 3.2. We want to end up with, so that's our A. If compounded quarterly, that means that our N is equal to 4, because that means they go in 4 times, quarterly means 4, they go in 4 times a year to add interest. So A is our ending amount. We want to end with $5,000. P is our starting amount. We want to start with $3,500. 1 plus our rate is 3.2%, so we change that to a decimal, so 0.32. Over N, the number of times compounded is 4, to the power of N times T, 4T. The question is how long, so T is our variable. All right, so I'm gonna go ahead and first thing I'm going to do is go ahead and get rid of the number that's in front of here. I do wanna switch sides. I don't have a whole lot of room, so I'm gonna kind of divide and switch sides at the same time. I'm going to divide both sides by the 3,500 to get rid of that piece attached to my exponential part. And then I'm also going to switch sides. So I'm going to put my 1 plus, I'm going to do that part in the calculator. All right, I'm going to put this in my calculator, figure out what that is, and then I'm going to do this part as well. I think I'm going to leave that part kind of as a fraction, but I'm going to do 1 plus 0.032 divided by 4. 1 plus 0.032 divided by 4. So I get, it's a 0.32, 1.008 to the power of 4t. So this piece right here is this, and then I'm going to go ahead and simplify this, but I switch sides, so I'm going to write it over here. I can cancel out these zeros, and then 50 divided by 35, both of those can be divided by 5. It'd be 10 over 7. It's a decimal that doesn't end. 10 divided by 7, it just kind of kept going on forever, so I didn't want to write it, all those decimals out. Okay, so now this is an exponential problem. I can't find my exponent because I don't know 1.008 to what power is 10 over 7. So I'm going to switch it to logs. So I do log base 1.008 of 10 over 7 equals 4t. I'm going to go ahead and kind of do everything in the calculator at once. So I'm just going to go ahead and hit divide by 4, and that's going to give me time. I want hundredths, so I'm going to do 2 decimal places. So log base 1.008. So I do my log base 1.008 of 10 divided by 7, and then we want that whole thing divided by 4. So I get 11.190, so 2 decimal places of 11.19. And this is years for our time. So again, we took all of the key information, our starting amount, our ending amount, our rate, how many times it was compounded, and we plugged all of those numbers in. Then we went ahead and we got rid of what was in front of our parentheses by dividing. I put that over here, 10 over 7, and then we simplify what was in the parentheses to get 1.008, and then we did our loop trick to change form so we could solve it. I have my log here, I plugged in the calculator, I did divided by 4, and I get 11.19. So that's how long it would take to go from $35,000 to $5,000 if you just left it alone, never touched it. You're going to take 11 years to gain $1,500 interest if you're at 3.2, which is actually a high interest rate. All right, let's do our compounded continuously for B. So we're still using the same letters for everything, our numbers. So our A is still 5,000, our P is still 3,500, E to the power of our rate is still 0.032, and then T. All right, so I'm going to do the same thing I did over on the other one. I'm going to divide both sides by 3,500, and I'm going to switch sides. So I get E to the power of 0.032 T equals, and we already know what we get when we simplify that because we did that earlier. It was 10 over 7. Now I'm going to go ahead, and I can't solve this because I don't know E to what power would be 10 over 7. So I'm going to go ahead and do my loop. That would be log base E. We don't write log base E though. We go ahead and write natural log of 10 over 7 equals 0.032t. I'm going to go ahead and just only have to use my calculator once. I'm going to divide by 0.032, and that's going to give me t. So I have Natural log of 10 over 7 divided by 0.032. So natural log of 10 divided by 7 divided by 0.032. So I get 11.146. We're rounding to 2 decimal places, so 11.15. So years. So it's not that big of a difference. So it's going to be faster. Oops, I meant the highlighter. It's going to be faster, 11.15 instead of 11.19, if it's compounded continuously. That means that they go in and they add money all the time, you're earning interest rate, rather than just 4 times a year they go in and add the interest rate. So it makes a bigger deal when you have more money and better interest rates, but it wouldn't take that much longer. All right, so we're going to put this into our digital notebook. This was slide 17 and 18, if I'm not mistaken. And then you guys are going to do some practice problems for homework.